Hey everybody, this is Steve Hess from OpenBOM. We're going to get started in just about a minute. If anyone can hear me, could you please maybe post a comment or raise your hand in the chat? Just let me know that you can hear me. Anyone? Okay, we're going to go ahead and get started. Okay, can anybody hear me? Okay, I'm just okay. Just trying to confirm that you guys have some audio. Okay, just trying to confirm that you guys have some audio. Okay, it sounds like everyone can hear me. I'm going to go ahead and get started. Welcome to the webinar, everyone. My name is Steve Hess. I am the Director of User Experience at OpenBOM. We are going to discuss today part numbers and specifically whether they an intelligent part number versus just a dumb part number, what the merits are of both. And I'm just going to take care of a little business here at first to get started. This is a 30-minute webinar. It's designed to be a thoughtful discussion about part numbers and types and methods. This is not a deep dive into part number or BOM theory. At the end, I will suggest a path forward, and it's definitely a marketing-free event. So, okay, I'm just going to throw up on the screen here a definition of part number, and I'll let you read this, but part number is a unique identifier. This is from Wikipedia and designed to simplify the reference to the part. It needs to be ambiguous, and a part, examples of what a part might be are listed there. But obviously they can include anything from a part to a document, raw material, labor, anything that is consumed during the process of manufacturing your product. So I'm going to rely on the example that we've been using in a few earlier webinars on the skateboard. And we're going to just take a quick look at, how would we build this skateboard? And I know what all the bits and pieces are. I even know what the product structure is. But of course, how do I knit it all together? And the answer to that is part numbers. So the part number is the lifeblood of manufacturing. And what I'm showing here is a BOM from one of our earlier webinars for the skateboard. And we can see that all the information that comes from that's either in the BOM or in a master database is all referenced through the part number. So part number uniqueness and ease of use are very important. And by the way, I'll share this slide deck as well as the recording of this presentation with everyone after. I'll also try to keep an eye on the webinar panel. If you have a question, please go ahead and raise your hand, and I'll try to grab it as we go. By the way, I see a lot of familiar names as well as quite a few new names on the call, so I would like to welcome everyone again. Okay, there are basically two types of part numbers, and this is the essence of our discussion today. And we're going to refer to them as intelligent and non-intelligent. Intelligent part numbers are sometimes referred to as significant. And what that means is that the various locations and digits, positions within the part number have some meaning to the company or the organization. Here's an example, again, right out of Wikipedia. I think that would be, we all recognize this as just as a mess. But here we see that that each one of these locations has some meaning, and understanding what that meaning is and what the individual position means is the challenge of everyone in the organization. The sort of the alter ego or the counter to that is the non-intelligent part number, sometimes referred to as dumb part numbers. They typically start at a particular sequence. You know, in my example there, they start at 1,000 and they just march forward as we add new parts to the company, our processes. We just we take the next number in a sequence. There's plenty of numbers obviously available to us, and we just take the next one. So those are the two sort of competing part number methodologies that I see in manufacturing today, and as a matter of fact, going back many years. So let's take a look at the two of those, what the pros and cons are of each, and see if we can distill it down just a little bit. The significant part number has been around, is much more of a legacy item, has been around for quite some time. And we all know what the benefit of that is. It allows that part to be recognized easily by its part number. I can look at that part number if I'm in an auto parts store, and I can see that that's a oil filter for a Chevrolet. Everyone in my organization is familiar with this part numbering method, and it makes conversation and things easy within my organization. The downside, the con to that significant part number is there's a significant amount of maintenance, an ongoing maintenance that's required to maintain it. Adding a new product code or some metadata about that part number is difficult. If I'm using a digital or even a paper system, I've got to get buy-in from everyone in the organization about adding another dash number to the part number or another recognized code that's buried within the part number. It's difficult, time-consuming, and an ongoing chore to maintain it. Keeping in mind again that a simple change to a part number can be difficult. In my own experience, I can speak to that in the semiconductor business. We'd had many meetings just on part numbers. So the second type there is the insignificant or the non or unintelligent part number. And what's the benefit of that? Wow, it's easy, it's fast. There's literally no maintenance of the part numbering system other than to keep track of the next available part number. And it's easy to dispense that, and doesn't require a lot of analysis or institutional tribal knowledge about how the part numbers work. Easier to bring new folks into the organization. If you've got a flexible workforce, people come and go. Training and costs because of it are naturally lower. What's the downside of this? It does require a flexible and organized open system to manage BOMs and and your products. In order to really be effective, this insignificant part numbering method needs to have some way to connect metadata, other data about the part number to that part number. Information that we used to embed in that part number now is stored separately, and there must be some way to associate it and then retrieve it when needed, so that the engineer, from the engineer down to the people that are manufacturing it and eventually onto who's shipping it out the door, they need to have access to this system so they can understand all the data. So in a nutshell, that kind of balances the two competing interests of those two systems. Let's just take a quick look at the significant part number and why it's around and why does it still have so much traction. Typically, legacy systems that have been around for a while use this part numbering method for a couple of reasons. Number one, they were typically closed silos. They didn't have that flexibility. We were just talking about folks downstream in my manufacturing process, or certainly in other buildings or in subcontractors, didn't have access to it. So when I sent a part number to a subcontractor, often that part number just really had to say everything about the part. And here's some things that I know that I've heard, and we probably heard before, about why people are drawn to the significant part. I just want to add some product code to it, or perhaps I don't know where to store revision, and I like to put revision in the part number because I know part number gets distributed to everyone, and the list goes on. So let's kind of drive this down a little bit further and take a look at what a typical legacy bill of material looks like. I'm going to kind of focus in on kind of usage of each one of these part number methodologies here. There is a typical bill of material comes out of a legacy system. It's generally, you can see, sort of generally done in Excel. I would venture to say that to this day, 80% of the manufacturing BOMs were probably still done in Excel, or have some portion of them done in Excel. Part number, quantity, description. You can see, some of the shortcomings here. Even in my own presentation, I've got description spelled wrong. So there's a lot of shortcomings when keying in this information. And here's maybe what some typical part numbers might look like in my organization. The responsibility lies with the designer in many cases to maintain this Excel and keep it, keep all that information current. Okay, so let's compare, quickly, the two systems. We know what the intelligent part number might look like. We saw an example of that here. In my example for our skateboard, I've got product codes and revisions and other things are embedded into that part number. This particular item happens to be, a part of the deck assembly, and it's, the deck is 32 inches long, and -1-A says that this is a purchased item. It's currently a Rev A. That's okay. That works as long as everyone understands that, can decode the part number. The non-intelligent or unintelligent part number system looks more like what we've got below, a sequential part number with some metadata stored about it. And in the end, eventually will convey exactly the same information. Okay, with that, I'm going to just jump into a live demo. This is meant to be informal. I'd like to encourage people to ask some questions along the way, and let me take you through a demo. I'm going to try to highlight some of the shortcomings that we just discussed, and then move into how to manage a bill of material using a non-intelligent part number, and then ultimately maybe how we might kind of blend the two. So let's take a look. First, let's see. Let me move this off to another screen so we have a better view here. Now, first, let's take a look at that Excel. Again, this is typically how it's done. Gosh, I've got a typo here, that needs to be corrected. See, I've got another one here. Typos, data enforcement are just hard to do. They're hard to do in Excel. My typos and mistakes in my part numbers, since they're so more complicated, are much more prevalent. So, but the big thing that I want to point out here is, and in my particular example, I'm really making a big mistake in that I am storing a revision in my part number. Now, why is that important? Because as this part kind of goes through a revision life cycle, and we'll see that a little bit more later, my part number is going to change. So the cost of maintaining, again, that just adds to that cost of maintaining and updating part numbers. That may also affect, my product structures and things like that that I maintain that are based on part number. Let's take a look at the tape in this one. In my example, I've got the -0 here, which says, hey, that this is, this is a non-purchased item. So if we decide to, if we decide to go ahead and buy that item for this particular BOM, I need to change that information in 2 places. That's got to go from a -0 to a -1. Again, problems associated with having to maintain the data in 2 places. So that as well as some of the other things here. Another example that I'm making is that is a lowercase n the same as an uppercase n. I have to be able to understand that -n here says it's a nylock, and -3 means it's a lock nut. Again, I have to have the secret decoder ring in order to decipher the part number. So there's a few of the shortcomings of the Excel with the old sort of significant part number. So what I'd like to do now is just jump ahead to taking a look at a bill of material that is built around an insignificant part number. What does that look like? So here's a BOM, and forgive me, I'm going to change my zoom factor here to try to improve the view. Let me give that a second to update. Okay, so here's the bill of material that has part numbers as we expected, a sequential order of part numbers. The metadata is stored in one and only one place. Let's go ahead and add an item here. I'm going to use the add item feature. I'm using OpenBOM right now. I'm going to use the add item feature in OpenBOM into this bill of material. And let's add find a part number that let's add the 1001. Okay. I've already got that. Let me add the 1001 to this bill of material and say that there are 4 wheels. Okay, so that's simple. That information comes in here and fills out automatically in my BOM, and we might ask ourselves, well, where does that information come from? And that information comes from an item master, which I want to demonstrate in just a second. But by using a system like OpenBOM, we also get some other information. We get some data validation. So I understand that in my case, quantity must be a number. I also am using a set of property names that are predefined by my company, excuse me, and so that I know that spelling and other things are also validated. And again, no information stored in the part number. Okay, So we just showed what we could do to add an item in here by adding the wheel in. Let's take a look at the information that's stored behind this bill of material. This is in OpenBOM, we call it a catalog. Other systems you might refer to this as an item master. So here's an item master catalog for our skateboard. And I have some part numbers established here. I'm also using some capability inside OpenBOM here for some part number enforcement. This is where I've gone ahead and set up the various ranges and other things that I want my part numbers to follow. In my case, I've said let's start at 1,000. We're going to increment by 1, and I'm going to end at 9,000. I'm also going to change a few things. So I'm going to say let's go ahead and enforce part number uniqueness. That's very important. I also want to automatically generate part numbers. This is where the ease of use comes in. Automatically generate some part numbers. Let's add some more parts to what are some of the things that might exist in our skateboard? I click add item, I get the next available part number. Let's say this is an axle, it happens to be 8 inches wide. This is a part, and it's going to be a Rev D. So I just added an axle to my catalog. $1,007. This could be a nose guard. Doesn't happen to have any size. Take this apart. And doesn't have any revision. Okay, so the work done in the catalog and the item master is very important. Again, associates it with a single part number. Let's go back to our bill of material. Let's add a few more items to kind of complete this. Add that axle. Let's see if there's 2 of those. Add that nose guard, 1 of those. Okay, so with a system like OpenBOM, this can be shared with everyone in my organization, very Google-like. And this is the way that all this information can be conveyed to my downstream manufacturing and the other members of my organization, my extended organization, so that they see this holistically with all the information associated with it and available to them. So that's where we overcome that shortcoming or that need. We feel that need to put all that information in the part number. So finally, I want to point out one benefit of using this item master process, and I can do things like add cost. And I see that I'm just going to go ahead and add a costing here, just to make everything $1. And when I return to my bill of material, that information will be displayed. And here we can see that information here, cost. So that's that single source of information. As I change costs and things in my catalog, I'll automatically be reflected in my bill of material. So that's the case that I'm making for using a system with a less significant part number and not storing any additional information in part number yet, and then storing that in a system that can manage and distribute all that information. So I'm going to bring my slide deck back in and jump ahead to I want to wrap this up and leave time for questions. Jump ahead to suggestions that are from me on creating part numbers and a part number plan. Listen, I realize that you may be at a company that has a long, history of part numbers. You may be a startup that's just thinking about this right now. So take this for what it's certainly for what it's worth. In my experience, 8 characters, and I use the word character here, 8 digits is a long enough part number. 8 factorial is over 40,000 part numbers. So let's keep them manageable. When they're sequential or insignificant, as we say, there's no need to have these long part numbers so that I can include a digit for every possible piece of data that I want to store about the part number. 8 characters is long enough. Use numbers. In my experience, use numbers, not letters. Is the dash n the same as the dash lowercase n? If you must use letters for some reason, always use caps. Some other recommendations here is, no leading zeros. Stay away from, special characters that are on the shift keys of your keyboard, as well as, periods and spaces. And if you need to, you can include a dash number. OpenBOM will let you configure a mask that you can, break up your part number into, some pairs for readability. Something to consider. Keep in mind always that the dash is never part of never part of the part number. The numbers are the part number. And of course, you always want to use some tool that will let you enforce uniqueness, whatever you're using. Duplicate part numbers is not a good thing. So we also saw, and I recommend that you never store information about phase in the part number. When you build it, you've got a bill of material built out, and you've got a part that's simply going from proto to release. If you have to change the part number from a dash P to a dash R something, you cause all kinds of havoc, downstream. So essentially, you're cause the rest of your organization to update bills of material, maybe update ERPs for no product change at all. It's just a phase change. So revision, state, phase, maturity, all those type of things really never belong in the part number, and that goes with obsolescence as well. Seriously consider enforcing form, fit, and function. We can deal with this in an upcoming webinar. In a nutshell, form, fit, and function says that the Rev A of this part and the Rev B of this part are interchangeable. So I can go to the bin where I store the parts, and I've got the Rev B or the Rev D. I can grab either one of them out of the bin, put it on my product, and they'll work. If that's not the case, using form, fit, and function, we get a new part number. So let's consider that. Perhaps we'll deal with that in an upcoming webinar. And in the company that I was in, the semiconductor business, I just want to tell you that making a part number change took weeks and cost $10,000 in time. So here's a few references that I want to share out. I will, like I said, we'll share this slide deck as well as the audio and video presentation. And at this point, I'd like to take a few questions. I'll stay on. I know we're running, we've still got a few minutes left, but perhaps we can grab a question or two and I'll stay on as long as needed. You can always submit questions to support@openbom.com as well and get a quick response. So, okay, let me take a quick one. What about supplier part numbers like make, master, car? How might I manage those? Okay, let me return to our item master. And again, I'm using a system that has a flexible property list. So I'm going to add a supplier link to my catalog. That is right here. So that's going to be a new property that's available. And I'm going to go ahead and just open up MasterCard quickly. And let's find something, a weld nut. and I'm going to grab the URL to that weld node and return back to my OpenBOM catalog. Edit that reference, display that URL, and also display this as the part number, and update that. So now I have a link in my catalog called supplier link, and any bill of material which is consuming that item will get a property called supplier link. So I'm sharing this with the guys on the machine, in the assembly or on the machine shop, or if someone is doing my final assembly, and when they click on this link, we will take them to the McMaster-Carr page for that part. So that's a nice enhancement to using a method like this with associative data where I can store that additional information. Okay, let's take one more. My company currently puts a version in the part number, and they're talking about they have the same issue that we just discussed. What's the best way to eliminate that? Well, let me make a suggestion. Let's go back to our catalog, and let's just add another property here. And let's call this legacy part number. These are predefined. If legacy part number wasn't defined in OpenBOM, I could go ahead and create it. So legacy part number, this is a nice place where you might store, your old part numbers. Type it right there. So if I create I've kind of moved on. I'm thinking about slowly migrating to insignificant part numbers, but my company has a long legacy of significant part numbers. I can add a column in my catalog to capture that part number. And again, when I return to my bill of material and consume that item or reference that item, I'll see that my legacy part number is mastered there as well. So you can sort of envision, even in someone downstream looking at this and saying, okay, look, here's the new part numbering system. I can still search. I can still have comfort in looking at that legacy part number. Okay, I realize we're running a little bit long, but I'm going to stay on here and take one more. Yeah, the question is, couldn't I do the same thing I just showed with significant part numbers? And the answer is yes. Much of the information we just demonstrated about associating, this information with a part number. Yeah, this could be a significant part number with a dash P for product code and all that stuff embedded in there. But I just want to take you back that in doing so, every time that part went through a phase change or got a revision, I'd have to change its part number. And again, anything downstream that was referencing that old part number we'd have to find it and update it, and that can often be hard to do. So, okay, thank you. I do want to thank everyone for attending. Again, if you have any additional questions or comments about this webinar, please send them to support@openbom.com. I just want everyone to know I am trying to manage the latency issue that I heard about from the last webinar, so I'm trying to improve that a little bit. So stay tuned. So anyway, thanks for joining. I hope you enjoy your Wednesday. Have a nice day. Bye-bye.